So this is the task. The goal is to implement the retrieval-augmented generation pipeline that allows users to interact with structured and unstructured data. So the task is chart with website using a RAG pipeline. So my implementation code is, so this is my implementation code for, for the chart with websites. So here it is. So request. So request library which is used for making HTTP requests to fetch website content, and next one, so which is BC4 library, so which is used for, so parses and extracts data from HTML web pages. So beautiful soap module. So from sentence underscore transformers, so import sentence transformers, so which is used for converts text into vector embeddings for semantic understanding used in NLP task, natural language processing tasks. So next one, import files, so which is used for a library to perform efficient similarity search in high dimensional spaces, so used for storing and searching embeddings. So next one, import OpenAI, so which is used to call the GPT model, so from OpenAI to generate the responses. And next, NumPy, so which is used for work with arrays, used to combination with files for the indexing. And next one, Streamlight as a ST, so a Python framework for building interactive web applications, so which is used for GUI, so graphical user interface for this implementation. So next library, so concurrent.futures, which is used for, and from concurrent.futures import thread pool executor, so which is used for manages multiple threads to process website concurrently. Next, which is pickle, so the serialize the objects used to save and load files, index and metadata. So okay, so first of all, setting up open API key, so I remove the key and set as open API key, so we have to add the key here. So the open API key is set with your open API key to authenticate the request made to the GPT model. So model initialization, so sentence model initialization. Sentence transformer initializes the pre-trained model all mini LM L6v2 for generating embeddings for the text chunks and user queries. Next, next, fast index initialization. So here it is, the fast index flat L2. So dimensions, create an index with L2 Euclidean distance metric for similarity search. It stores vectors with 384 dimensions. The output size of the sentence transformer embeddings. This is used, it is array, metadata storage array. So a list metadata is used to store relevant chunks of content along with their document name. So this metadata helps associate the content with its source after the content is indexed in FAS library. So next is the function which is used for the scrapped website function, which is used for sends an HTTP request to fetch content from a website and parse the HTML content of the website to extract the meaningful text from the a specific HTML tags P1, H1, H2, H3, Li, span A, and etc. etc. We have to add more. Next, text extraction. So all the text is extracted and chunked into a small pieces. And to improve the granularity, so chunks are then used to generate embeddings and for indexing files. So we have to return the chunks. So next function, so index underscore chunks, which is used for embedding model encode. So convert the text chunks. So convert the text chunks into the vector embeddings. So it will convert the chunks into vector embeddings. So index.add. So adds the embeddings to fast index for efficient similarity search. So metadata is also updated. to store the chunk content along with the document name. So next function, processing multiple websites concurrently. So process multiple website function, so which is used for thread pool executor, manages multiple threads to concurrent. So manage multiple threads to concurrently scrap and index content from multiple URLs. So for each URL it scraps the content and chunks into before indexing the embeddings into FAS. So next function, save index function. So saves the FAS index and metadata to disk. The index is stored using face.write underscore index and the metadata with pickle.dump. So load index. So load index, which is used for loads the FAS index and metadata from the disk, which allows the program to resume processing without having a scrape websites. And next, detecting intent. So analyze the user's query to detect the type of response required. For example, comparison, summary, general query, like that. So this helps in tailoring the response appropriately by the providing context to the GPT model, OpenAI model. Next function, which is querying the face index, query underscore content function, which is used for querying the face index. So this user query is encoded into a vector embeddings. So next function, generating prompt for GPT-4. So which is used for construct a prompt using the relevant content retrieved from the FAS and the user's query. So if the query is a comparison, the prompt is structured to compare the retrieved content. Otherwise, it is structured to answer the query based on the content. That's why this function. So next function, that is generating response with GPT-4. So generate underscore response function. So calls the OpenAI GPT-4 model to the generate a response using the prepared prompt. So the model processes the prompt and generates a response that incorporates the retrieved context. So next one is Streamlight UI. So which is used for graphical user interface to the user for this implementation of this code. Okay, so next how it works. So first of all, the user provides URLs to the scrape and input a question. So we have to execute this one. So I am executing this. So streamlit run app.to.py. So it will go to the redirect to the web page. It redirecting to the web page. So it is running. So we have to provide the URL link to this application, and we provide the questions, and it will give answers for us. So okay. So this is my portfolio website. So I wanted to give this website to my application. So Control C. Still it is running. Okay. So chart with website using RAG pipeline. This is my project. So this is my task. I am providing the URL and Control Enter. So it is fetching whether it is URL is working or not. Okay. The website processor and indexed successfully. So now we have to ask questions to this model. So the first question is who is Dontaraveni Rajendra? So who is Dontaraveni Rajendra? So I already provided. So I am a Dontaraveni Rajendra, computer science and engineering student, a 4th year undergraduate engineering student at Vagdevi College of Engineering. So and here I am provided about myself and skills, qualification, projects, certifications. So all I have provided. So we have to so it giving response to us. So, who is Dontarvin Rajendra? So, Dontarvin Rajendra is a fourth year undergraduate student pursuing a degree in computer science and engineering at Vagdevi College of Engineering in Warangal, Telangana, India. So, he is skilled as a full stack Java developer. So, it gives me about myself and my score and my email ID, so on. So, we will ask another question. So, what are the uh, what are the internships? Intern. So what are the internships that Tantarveni Rajender completed? Has completed. So what are the internships that Tantarveni Rajendra has completed? So we will wait for the response. Okay, so the response is good. The Dontarveni Rajendra has completed the following internships. So full stack web developer at Coding Raja Technologies. So Java developer internet System Solutions and Java programming internet the Blackbeards. The Python developer internet System Solutions. So check certifications, internships and achievements. So these. So I completed 4 internships and the response is also showing like 4 internships. So the model working very well. So I am one example URL I am taking. So that is this URL. It is a university website. So I am providing control enter. So what is this web URL? So net issue. Okay. So website under the processing and indexing. So okay, the website is processed successfully and we have to ask the question. So first, what is this URL? So we have to know. So it is the university, a field defining scholarship. We value regions inquiry. So we foster independent thinking. We advise ideas and humanity. So this is a University of Chicago. So I am asking about so what is University of Chicago? Which is University of Chicago? Still running. Okay. So which is the University of Chicago? So we will wait for the response. So okay, the response is coming. Okay, the University of Chicago is a private research university located in Chicago. So and founded in 1890, it is the known for its rigorous academic programs. So it gives all the information about the Chicago University, which is in the web page. So let ask one question. So we value rigorous inquiry. So a diversity of people. Okay. So intellectual freedom. So ask this about the intellectual freedom. So what is intellectual freedom according to the University of Chicago? So what is intellectual freedom according to according to the University of Chicago. So wait for the answer and a response from it. Okay, the response is generating. So the coming response from it. Okay. So intellectual freedom as defined by the University of Chicago refers to the right of individuals to access and share ideas and information freely without censorship or restriction. So we have to check. So learn more. So there is a internet issue. Okay. So the response is related to that website, and also one more question. So what are the projects? So what are projects of Dantaraveni Rajendra? So I'm asking about the first URL question. So oh. So the website is so what are the projects of Dantaraveni Rajendra? So it generating a response. So automatic irrigation system and the website for previous year question papers. So my projects are projects. So website for previous year question papers. So okay then, thank you, and my task is completed.